A child takes one bite of a peanut. Nothing about it is poisonous. For most people, it is just food. But within minutes, the child's skin turns red. Their lips begin to swell. Breathing becomes difficult. Blood pressure can suddenly fall. The peanut is not attacking the body. The immune system is. A defense built to save lives has mistaken dinner for a deadly threat. And sometimes, the reaction becomes more dangerous than the substance that triggered it. So why would evolution preserve a system that can nearly kill us over food, pollen, or a cat? The answer begins with an alarm, designed for a much more dangerous world. An allergy usually begins before the first obvious reaction. The immune system encounters a harmless substance, perhaps a protein from pollen or food, and makes a terrible decision. Danger. It produces a special type of antibody called IgE. These antibodies attach themselves to immune cells hidden throughout the body, especially in the skin, the lungs, and the digestive system. These cells are called mast cells. Think of them as microscopic traps, already loaded and waiting. The next time the same substance appears, IgE recognizes it. The mast cells explode into action, releasing histamine and other chemicals. Blood vessels widen, tissue swells, the skin begins to itch, the nose produces mucus, the airways may tighten. None of this is random. Every symptom is part of a defense. The body is trying to trap the intruder, flush it away, or prevent it from moving deeper. The problem is simple. There was never an intruder. The immune system did not fail to respond. It responded perfectly to the wrong target. But that creates a bigger mystery. If this reaction can become fatal, why didn't evolution remove it? Because this system was never built for peanuts, or cats, or spring flowers. It was built to detect danger quickly and force it out. Sneezing throws particles from the nose. Coughing clears the airways. Tears wash the eyes. Vomiting and diarrhea remove substances before the body absorbs more of them. Itching may have helped our ancestors notice parasites, then scratch them away. These reactions look unpleasant because they are supposed to be. They interrupt everything until the threat is gone. One theory suggests that allergic immunity evolved partly as protection against parasites, venoms, toxins, and dangerous substances in food or plants. The body did not need to understand the threat. It only needed to react before the damage became fatal. A person who quickly rejected contaminated food, noticed a venomous bite, or avoided a plant that made them sick might survive where someone with a slower response did not. That may be why evolution preserved such a sensitive alarm. Not because it was safe, because it was fast. Natural selection does not build perfect systems. It keeps systems that work often enough. And for most of human history, a few false alarms may have been less dangerous than ignoring one real poison. The same defense may also have helped fight large parasites. Worms are too big for many immune cells to swallow, so the body surrounds them with mucus, inflammation, and chemicals meant to push them out. Allergy appears to use parts of that same ancient machinery. Only now, the target may be dust, pollen, milk, or a protein from a peanut. The weapon survived. The enemy changed. But if the immune system can mistake food for poison, what teaches it which substances to fear? Two children encounter the same food. One develops tolerance. The other develops an allergy. Why? Part of the answer may depend on how the substance first enters the body. The immune system is not born with a complete list of everything that is safe. It has to learn. Food entering through the mouth usually arrives with signals that encourage tolerance. The digestive system is constantly exposed to unfamiliar proteins. If it attacked every meal, eating would become impossible. So the gut often teaches the immune system a simple lesson. This belongs here. But the same protein can tell a very different story if it enters through damaged skin. The skin is supposed to be a wall. When that wall becomes cracked by eczema, inflammation, or injury, proteins from the environment can slip through. There, the immune system may meet them beside damaged tissue and danger signals. Instead of learning, "This is food," it may learn, "This caused the damage." That creates a strange possibility. The same peanut protein, introduced through the digestive system, may become familiar. But encountered through inflamed skin, it may be remembered as an enemy. This does not explain every allergy. Genes matter, The skin barrier matters, the microbiome matters, so does the timing of exposure. But the central idea is powerful. Allergy may depend not only on what the immune system meets, but where, when, and under what conditions the meeting happens. And sometimes, one encounter is enough to rewrite the rules. A person can eat the same food for years, then suddenly become allergic after a single bite from an animal smaller than a fingernail. A person eats beef for years, without a problem. Then one day, a tick bites them. Weeks or months later, the same meal can trigger hives, stomach pain, swelling, or even anaphylaxis. This condition is called alpha-gal syndrome. Alpha-gal is a sugar found in most mammals, but not in humans. Certain ticks can expose the immune system to it through their saliva. The body may then label the molecule as dangerous. After that, beef, pork, lamb, and even some dairy or gelatin products can trigger a reaction. The strangest part is the delay. Most food allergies strike within minutes. Alpha-gal symptoms often appear between 2 and 6 hours after eating. A person may finish dinner, go to sleep, then wake up unable to breathe. The food did not change. The immune system did. One bite taught it to fear something it had tolerated for decades. This reveals an uncomfortable truth. Allergies are not fixed at birth. The immune system keeps learning throughout life. And sometimes, one lesson is enough to turn familiar food into an enemy. Yet another question remains. Why do allergies appear especially common in modern societies? For years, this idea was reduced to a simple phrase: children are too clean. But dirt is not medicine, and hygiene is not the enemy. The real explanation may involve the variety of microbes that train the immune system early in life. For most of human history, children grew up surrounded by soil, animals, plants, and large communities of microorganisms. Today, many spend more time indoors. Food is different. Antibiotics can alter the microbiome. Air pollution can damage the barriers of the skin and lungs. The immune system develops inside a world very different from the one that shaped it. One clue comes from farm communities. Children raised around livestock and microbe-rich dust often show lower rates of some allergies and asthma than children growing up in less diverse environments. That does not mean germs are always protective. Some cause serious disease. The important factor may be exposure to a broad microbial world at the right stage of development. Those early encounters help immune cells learn restraint. Which signals deserve an attack? Which should be tolerated? A poorly trained immune system is not necessarily weaker. It may be less experienced. Without the signals it evolved to expect, its alarm system can become too eager. Pollen becomes suspicious. Dust becomes dangerous. Food becomes a threat. Then scientists discovered something that overturned decades of allergy advice. Sometimes, avoiding an allergen did not prevent fear. It helped preserve it. For years, parents were often told to delay giving peanuts to children at high risk of allergy. The logic seemed obvious. No exposure, no reaction. Then researchers tested the idea. The LEAP trial followed 640 infants with severe eczema, egg allergy, or both. These children already had a high risk of developing peanut allergy. One group avoided peanut. The other regularly ate age-appropriate peanut products from infancy. Years later, the result was dramatic. Early peanut consumption reduced the risk of developing peanut allergy by about 81%. Avoidance had not taught the immune system that peanut was safe. Regular exposure often had. The digestive system had introduced peanut as food before the immune system could define it as an invader. This does not mean someone with an existing allergy should experiment at home. For high-risk infants, timing and introduction may require medical guidance. But the discovery changed how scientists understood prevention. Tolerance is not always passive. Sometimes, the immune system must be taught. And the lesson works best before fear has taken hold. Allergies are often described as immune overreactions. That is true, but incomplete. An allergy is also a memory. The immune system remembers a peanut protein, pollen grain, or molecule from mammalian meat and prepares for the next encounter. The problem is not simply that the defense is powerful, it is that the wrong lesson became permanent. A protein entering through the gut may be remembered as food. The same protein crossing inflamed skin may be remembered as danger. A substance eaten safely for years can become threatening after a tick bite. An early introduction may create tolerance, while long avoidance sometimes leaves the immune system untrained. The substance alone does not determine the outcome. The route matters. The timing matters. The condition of the body matters. Your immune system is not working from a perfect list of enemies. It is building that list from experience. And occasionally, it writes down the wrong name. A peanut cannot chase you. Pollen cannot bite. A cat is not a parasite. Yet the immune system can respond to all three, with weapons built for toxins, venom, and ancient infections. That is the paradox of allergies. The reaction feels useless today because the original danger is often missing. But the machinery itself was never pointless. It made our ancestors cough out irritants, reject contaminated food, fight parasites, and remember dangerous encounters. Evolution preserved it because a fast alarm could save a life. It did not guarantee that every alarm would be correct. Modern medicine often treats allergies as mistakes to control. Evolution sees them differently. Not as proof that the immune system is weak, but as the cost of a defense that learns, remembers, and reacts before it knows the whole story. Sometimes, the body attacks nothing, because long ago, hesitating against the wrong enemy was more dangerous than attacking the wrong one.